Right guys, so I am recording this video to demo you this new tool called as structured prompt driven development. This was the tool that was developed by a team at Thoughtworks. I came to know about this tool from the blog post they have published on the website of Martin Fowler. If you guys don't know who Martin Fowler is, please Google him. So this article gets published on his blog. I really found it very insightful, and I immediately decided to try with it. So this is a brand new project. It doesn't have anything inside it, as you can see. I'm calling it DBAT. This is supposed to be an active time tracker for browsers, and it is supposed to work for all the browsers. I have not developed even a single code file for this project at this point. All you can see here is a requirements folder, and inside that I have created this file called as 01. So inside this 01 file, you can see I have pasted the requirement. So this plugin is intended to help with productivity. With that, let's get going. So I'll give a short summary of what is structured prompt driven development. It is a philosophy more than a tool. Basically, it is an agent harness. Structured prompt driven development is different in the sense that it is backed by a very solid philosophy. Now let's take a look at their philosophy. So if you're really interested in exploring what is structured prompt driven development, you can go through this article. To give you a short, they follow this model called as reasons-canvas, wherein you do not prompt the model one by one for each feature that you want to build, but rather you build a requirements document and then follow a structured flow according to this reasons canvas. So they are trying to give a structure to your prompt. Normally, whenever you get a requirement, you just translate it into English text and give it to your model, and then the model comes up with a plan, and then you review the plan, and then you implement the features, and then you go again and again with this kind of iteration. A lot of tribal knowledge happens here, right? So only you know why you have written the prompt that you have written. Once the code is generated, the prompt is gone. Your manager has something in his head, you have something in your head. You implement the feature, then you demo it to the users, and then the expectations don't match. SPDD tries to plug this gap, especially in the age of AI driven development, using reasons canvas framework. Right, so the philosophy here is that you save each and every prompt that you have used to generate your code. That prompt will be like your spec. You will be committing that prompt to your Git repository. It will stay there for reference. It will get versioned the way it changed, and whenever you want to make a change to your code base, you will not make it directly in the code. Instead, you will follow this reason framework to generate the spec, and only through the spec will you change your code. That way, when something is not aligning, you can trace it back to your spec, and then your spec becomes like a source of truth. So that is the broad philosophy that they are following here. This is very similar to the spec driven development. In fact, you can say that structured prompt driven development is just a logical extension of spec driven development, wherein you are even generating the spec through a structured template and a proper flow using the AI model. So these are agent harness commands that are available in this tool. The first one is called story. So you can just give a plain text requirements to this command, and it will come up with how many stories you can break down that feature into. SPDD analysis will perform an analysis on your code base. Then comes the reasons canvas. This will actually generate the spec document for you, and it will follow the reasons canvas that they have mentioned above. So you will have everything included in there: what the model is supposed to do, what kind of standard it's supposed to follow, what kind of security checks it is supposed to have, what kind of guardrails it is supposed to have, what is in scope, what is not in scope. Everything will be documented in this SPDD reasons canvas, the output of this command. Then comes the SPDD generate command. This command will actually generate the classes and actually make the changes to the code as is mentioned in this SPDD reasons canvas. Then you have SPDD API test. This will generate a curl base. So this is not generating your unit test. It is basically generating the integration test for you. Then let's say you implemented a feature, you tested it, and then you remembered, oh my god, I skipped this detail, or I forgot to mention this detail, and now that feature is not there in the generated code. So in this case, you're not supposed to write a new prompt. Instead, that you're supposed to use this command to update your existing prompt. You are going to modify the output of the previous output of the SPDD reasons canvas and pass that document to SPDD prompt update, and now your updated prompt will be used. Will do a delta internally and generate only the missing part, and that way you don't regenerate everything. Then SPDD sync. So let's say there is a small bug and it's so small that you don't want to use your tokens to fix it. You are a developer, you are confident what you're doing, and you just don't want to change the code as it is. When you make that code change, now your code is out of sync with this whole SPDD approach. In order to sync your code back, you can use this command. So SPDD sync doesn't take any input, analyzes your code, what you have changed, and that is fed back into your reasons canvas document. So the output of this command, which is the reasons canvas, which is your like a product requirement document or spec document, will be updated according to what actual changes you have made in the code. So this is extremely helpful code. It allows you to organize your code base and follow a structure while also leveraging the AI speed that you're getting. I love this. I have used this tool for a couple of weeks now, and I just love the kind of clarity structure I have got by using this tool. There's a beautiful readme which will tell you how to exactly install it, how to generate all the commands. You have to be careful, however. In the readme document it says if you use the OpenSBDD generate -- all, it also generates the optional commands, which is not true. It always generates only the mandatory commands, and the optional commands, if you want them, you can list them first using OpenSPDD list -- all, and then generate each command individually, whichever you prefer. So these are the 5 mandatory commands that you get: SPDD analysis, reasons canvas, generate, and sync. Apart from this, you also have API test, story. Story is a very useful command. So if you have like a return text about a feature that you want to develop, you can pass it to the story command, and it will give you how many stories you can break down the entire feature into, and then you can implement it story by story, which is amazing. Okay, so I have done all the steps till this point. I have done OpenSBDD generate all. I have also generated the optional commands that I wanted. Now let's get started. So this is my requirement. I will be starting with the story command, and let's see how it works. Right, so I'm going to say SPDD story. So if you just want to check if the tool has installed properly in your folder, then you have to go into your .antigravity. Because I'm using antigravity, in the .antigravity folder I have this commands folder, and inside that I can see all the commands are generated. I pass this document to my SPDD story command. I have given the path of my requirements document, which is stored inside the requirements folder, and the name of my file is 01. And it will read my requirements and create stories out of it. Then we are going to review these stories and give it to analysis command. Now, as per my experience, the output of the story and the output of the analysis isn't very different, and even the output of the canvas is not very different from what you get from the analysis command. So I'm planning to completely skip the analysis command. So it has created this new document called as user story 1 active time tracking code.md, and it has also created the second user story and this third user story, and it is still working. So let's see how many user stories it comes up with. I think it has come up with 3 user stories. So based on the requirements that I had passed to it, it has come up with these 3 user stories. Now let's review it. So this is the first user story, evaluation. So it will also come up with the edge cases, and it will ask you if it is not sure about what to do. So it is important that you read these generated documents very carefully. This tool, I feel, can even replace your issue tracking system. So I'll not do a bunch of review. Second story is about micro interruption tracker and attention fragmentation index engine. As I said, we also want to measure the quality of users' attention. So if a user is switching tabs every 10 seconds or so, and that way the aggregated time spent on a particular website is much less useful than the focus time that he or she spends on a particular website. So we want to categorize the tracking that we have done, and then we want to display it to the user as well. I just want to be sure that we have provided that we want to have a proper display. I have specifically instructed it to have minimum memory and CPU footprint. So the background service worker that we are planning, which will be actually doing the tracking part, should go to sleep if the user is not active. I'm slightly worried about this because it has not mentioned that we need a UI for this. Okay, so this will be a good point to demo the update command. So let's go with this. So it has created these 3 stories. So the next command after story is the analysis command. So spdd analysis, and pass the story and do the analysis. In the second window, I will do a SPDD analysis of the second story, and in the third window, I will do the analysis of third story. So all the stories are being worked upon simultaneously. Okay, so story number 1 is ready. Let's review. So as you can see, it has written this document in an agent-friendly manner, but you as a human can also refer to this. This is a nice thing. It's complete with all the acceptance criteria and everything. And what are the technical risks? What are the edge cases? What are the requirement ambiguities? So I'll suggest, if you're planning to actually use this tool, read this section very carefully, because here you might need to make some changes. And if you feel you need to make some changes here, just change the text here before passing it to the next command. It's as simple as that. One more feature which I love about this tool is it clearly defines the scope in and scope out feature. This is perfect. I don't think this has factored in for the multi-browser requirement that we had. This is also something that we need to take care of. Yeah, this looks good. Now look at the assets that it is generating. It has generated this SPDD folder here, and inside this folder it is generating these assets. Let's look at the name of this file. Yeah, it's called active time tracking code, right? So we can trace it back to which user story it came from, this user story. Okay, all the stories are ready for you. Let's do this tracker story. Tab switch fragmentation tracker. Let's read the scope in and scope out part. Alright, now we'll move to the next command, which is the reasons canvas. After analysis, we generate the reasons canvas. So okay. If you guys So this reasons canvas is ready. Generating reasons canvas for the second story. So look at the safeguards, and now the next. This is the reasons canvas for third story. Now as you can see, this browser state listener I think we had in the second story as well. Now let's check. Yeah. Now here this class looks like bind listeners, void, handle tab change. Okay, and for the third, handle tab change, window focus, and idle state. And for the third, what it was, bind listeners. So okay, so it's not repeating itself. That's a wonderful thing. Now comes the moment of truth. Now we are going to use this command spdd-genrate, which is actually going to generate the code. Earlier, when we run the analysis command, all our analysis were generated in this folder. When we generated the SPDD reasons-canvas, all our prompts were generated in the prompt folder. Now next command is generate, and we'll be just passing these documents story-wise to the generate command. Alright guys, so I have generated the code for all the three stories, and now we are going to check how our plugin is working in action. I'll run npm run dev. It has opened a Chrome window, and because we did not have any UI, you will not be able to see any UI here. So here you can see our plugin has been activated. It is running, and this is the browser window. There is no UI. So I have tested it using YouTube and HackerRank. I have spent some time on YouTube. I have spent some time on HackerRank. I have changed few tabs, and in extensions you can see here is our extension. If you click on this service worker link, you will get this kind of a console. You have to go there and paste this command, chrome.storage.local.get console.log. Now this will bring you the internal storage of Chrome, which we are currently using to store our statistics for the screen time tracker. And as you can see here, for today's date, it is showing me the categories of websites that I have visited, my productive time, my neutral time, what domains I have visited, what is my attention fragmentation index, and how many tabs I have switched. So this is a very useful information for anybody who wants to track their productivity and are aiming to improve the way they spend their time online. So that's it for this video guys. See you in the next one. Goodbye.